Welcome back to the Experimental Aircraft Channel. I'm Brian Wallstrom. Today we are talking about a German design ULF-1 sailplane. For those of you who enjoy building with wood, this is the episode for you. Coming up next.
Ja, hi, my name is Holliday Obrecht und dies ist mein Segelflugzeug ULF 1.
Wait a second, let's translate that. If you could tell me about how this project came to be and how you chose this as a project and so forth.
Sure thing. I'm a member of EAA Chapter 309, and at the time, about 6 years ago, the chapter was looking for a group build project. And I'd always had in the back of my head that I wanted to build a ULF-1 microlift sailplane that was designed back in '78, and I knew about it back in '78. Never had a chance to build it, but this was my opportunity.
Okay, so again, this is the ULF-1, and is this, I would assume, 100% from plans, and you're having to fabricate every last little bit.
Exactly.
Piece?
We got a roll of 38 sheets of paper.
38 sheets of
from
paper.
Dieter Reich, the designer in Germany.
Okay, and is this a very easily available plans for anybody, or did you have to talk them into sharing a set of plans?
No, he has them for sale. Anybody can buy them. Yeah. So.
About how much is it?
Oh, they're roughly in the neighborhood of $200.
That's not bad at all for a set of plans.
Yeah. So yeah, it's and he's a designer. He came up with the design in 1978.
Okay.
And the goal was to develop a foot-launched hang glider that could beat any of the flexible wing hang gliders of the era.
Okay.
And that was his design goal.
And I assume there's maybe a materials list that comes with it, so you can go shopping to get all the parts. And
not really.
No.
It gives you a basic idea of the different material types.
Okay.
But then you have to come up with your own quantities.
Okay.
Which is a bit challenging sometimes.
So you kind of measure up from the plans of the square footage needed and
exactly.
Place your
yeah,
work.
and it's mainly spruce, Sitka spruce. It's Finnish plywood and foam and balsa.
Wow. Okay. And what's also very unique about this is that you are using something unique to power it with. And what is the plan for that?
We're going to use electric motors. Well, we actually have yet to finalize the design, but we've calculated that we'll need 2 4 to 5 kilowatt motors.
Okay.
Okay, and they'll be in twin pusher configuration.
It's a twin.
It'll be a twin, and each wing will have its own motor pod in a pusher configuration, and there'll be a speed controller for each motor in the cockpit, so we can adjust the speed of each motor.
Okay.
And they'll use that set of battery packs right over there that weigh about 39 pounds.
Now, is this one of those that the motor and mount will be fixed, and then the blades will collapse, or the whole assembly tilt?
No, there'll actually be a carbon fiber pod that will come straight out of the wing and stick right out of the wing about to here. I have a mock-up over here that I could show you real quick if you want to see how it's going to go.
So yeah, where this motor will be mounted at is the second bay inboard?
Second rib in from the root rib.
Okay.
And we've beefed up this whole intersection of the wing, this whole inboard root section, and the trailing edge of the spar. And there'll be a carbon fiber tube, 1 to 2 millimeters in thickness, roughly this diameter, that will glue right to the rear end of the spar and this rib number 2, and it will stick out about this far, and there'll be a hub motor mounted right here with a propeller that folds this direction.
Wow, and it'll literally retract back into the tube.
Yes. Yeah, well, it won't retract in, it'll just fold and slip back this way in the slipstream.
Okay.
So that's kind of our plan, that's our long range goal, and that's why we call it the ULF-1 N/T-E for new technology electric power.
Nice. And this original design was from what year again?
1978.
1978, and you're modernizing it, of course, now.
We're modernizing it with foam ribs because the original ribs were made out of sticks. You can see that one rib up on the wall there, that's a nose rib. All the ribs were designed to be made out of sticks, Sitka spruce sticks, and gussets made out of plywood.
From that to now, you've got the foam as the D section of the
We did, yeah. So what we did is we wanted to build the ribs quicker. If we were to build out of sticks, we would have had to make 13 different nose rib jigs, 13 different trailing edge rib jigs, and then lay up each individual rib by hand. Whereas with a sheet of 4x8 foam from what we call Lowe's Aviation Store, so to speak, we could get one of our club members to actually digitize each airfoil shape at each station, and with a CNC cutting machine we could cut a set of ribs out.
Nice, very nice.
Much quicker than building the ribs by. And then we also did load tests and found out that the ribs weigh a little bit less than the stick-built ribs, and when you put loads on them to destruction, they're actually stronger than the stick-built ribs. So we thought that building with foam was really the way to go. We did change the modification. We modified the wing joining system from, and I have a fixture over here that I can show you, from the original German style, which is supposed to have big rivets, but we simulated those with nuts. And what we did is we modified it with nylon lugs and 1/4 inch aircraft bolts. And when Dieter Reich saw that, he insisted that we do a load test where we actually put this on a load machine and loaded it to destruction. And he had a certain figure in mind, and ours came up to about 30% over what the maximum was.
Wow.
So he blessed this design, this modification.
That's a good safety.
Yeah, so we had a good safety margin. So there is some destruction testing that goes into any type of a modification that's made, to the airframe.
So what is the plus and minus on this then?
Well, let's see. I think the plus and minus. Let me just check to make sure I give you the right numbers. I believe it's +6 and -6.
Yeah. How rough of thermals are you anticipating up there, huh? So where exactly are you at the stage of this? I see the wings are the skeleton phase here.
Yeah, we are 6 years into the construction. We meet every Tuesday night for 3 hours from 5 to 8, and then I work in between. And the deal is that I supply the materials and the workspace, pay for everything, and I end up with the ship at the end.
Okay.
But believe me, without the expertise of our EAA Chapter 309 members, there's no way I would have taken this project on myself.
Nice. It's nice to have an active chapter.
Oh, unbelievable. I mean, and some of the fellows in the chapter, there's some fellows in there that know all about wood and how to build with wood. Fellows like Ross Gressley that have really been instrumental in keeping me on the straight and narrow.
Okay, Holliday, go ahead and school us on the board here with the stick, old-fashioned style here.
Well, we're 6 years into the build, and we've essentially built all of the airframe components.
Okay.
So we started with the tail. So we've got the horizontal tail, the horizontal stab and elevator all built. We've got the fin and the rudder built. They're hanging up on the wall. The rear section of the fuselage has been fabricated. The forward 2 sections are fabricated, and the seat box under here that contains the rudder pedals and the wheel, we can actually put landing wheels on it, has been built, and each wing has been built.
Wow, you guys really done a lot of work. Right, so this piece up here that you created, what is this called again?
This is called the seat box. This is actually where the pilot sits. All of his weight is bared on this.
Okay.
And this is the landing gear will be a single wheel here, 12-inch wheel,
all right.
Pneumatic bike tire. And these are all made out of balsa. These pieces in here are balsa. So it's an egg crate. So in the event of a hard landing, this is designed to crush but not transmit load to the pilot's backbone.
Oh, amazing.
Body.
So is this retractable? That's a fixed wheel?
No, it'll
there?
just be a fixed wheel, but there'll
okay.
just be a small piece of it that'll stick out in the slipstream in here. And then we plan on a steerable nose wheel, possibly fixed, but maybe steerable right up here on the nose.
Okay.
So it'll have 2 main wheels that it'll rest on, and then wingtip outrigger wheels. So it'll either be on one wingtip wheel or it'll be on the other. And then when the airplane gets ready to fly, you'll get that wing flying.
Or if you've got a 5-knot headwind, then you can
exactly you can
even
get that
up
wing
the
up,
wings.
or you can have a wing runner too. Either way.
Sure. Okay.
Yeah, so it's set up like a sailplane, a traditional sailplane.
And moving down your wall of fame here from your construction, is that the tail section of the fuselage there?
Yes, this is the rear section of the fuselage, the structure right here. So that's like the tail boom or the rear section of the fuselage. Of course, you can see the horizontal tail, the stab, and the elevator.
Is that something that I would assume that you build one side on the table, glue it up, and then put them together?
Yeah, the horizontal stab was all built as kind of what you start with first are the spars.
Okay.
So you build the spars. You can see the spar up there. You build those flat spars as a leading edge spar and a trailing edge spar, and then you fabricate your ribs, and then you connect the 2 spars together, and then you put the sheeting on.
Okay, you're talking about up top there with that's a horizontal stab then, right?
Yes.
I meant in front of it also. That's the tail of the fuselage, is it not?
Yes. Now this starts off with a flat piece on the building board down here, which is actually the top of the fuselage.
Okay.
Okay, and then what we do is we put these side support pieces on, and then put the keel in, and then connect the keel pieces with these diagonals, and then we add the gussets after.
Wow.
So that's the general procedure. And of course we've got the two main bulkheads, back bulkhead 1 and 2, where the wings actually connect to those, and those connect to the fuselage.
Did they act as jigs as you were building the fuselage, or no?
Well, we actually used bulkhead number 1. We laid it here on the building board with the main wing spars.
Okay.
And got the dihedral set during construction. And the dihedral the wing is actually flat across the top, but it has apparent dihedral because the ribs taper up to the wingtips.
Okay.
So, but the wing, as you see, it'll be perfectly flat on the top. And that's already been pre-done with those metal fittings on bulkhead number 1. And then bulkhead number 2 is where the trailing edge of the wing attaches. And then behind that, of course, is that big structure there to the right of the bulkheads is the fin. And behind that, you can't really see it as a rudder. It's a little smaller structure. It sits back behind there.
And again, what will this be wrapped in when you're all said and done with it, or?
I could show you an example of the Aura cover. It'll be the ultralight version of Aura cover, or Auratex, I guess they call it.
Is that the one that you can choose your color ahead of time, correct?
Mm-hmm.
So this is what, when you're all said and done with all the fabrication, you'll be wrapping, when you're all said and done, you'll be wrapping this with this Auratex?
Yes, this is the Auratex, the UL 600 version, and this is the natural color, because what we want this to look like a vintage sailplane.
Okay.
So we want the light to
have kind of an antique,
kind of an antique and translucent look. The light, sunlight will be able to stream up through it, and you can still see where the ribs are. And of course, you heat shrink it. It's put on with a heat-sensitive adhesive that you paint on. Let it sit 24 hours, and then the next day you take an iron and just iron it, and it'll bond right to the wooden structure.
Do you have to kind of glue this down to certain points first and then shrink it?
Yeah. What you do is you actually take the adhesive, which is like a white milky substance, and you paint it on every place you want the fabric to adhere to the airframe. Let it dry overnight, and then once it's dried, it's heat sensitive, and you can apply the heat and cover it. But we're not going to cover the leading edge, because that adds a lot of extra weight that we don't really need to put on the airplane. Okay.
We just epoxy seal that, or?
Well, the Auratex just needs to have 1 inch of grab on here to be strong enough for a VNE of 50 miles an hour. So we're talking
VNE
a VNE of 50 on this airplane. Yeah. So that's it. And then, but what we liked about this is, and when we covered the leading edge, we chose the nicest wood grain that we could find of the finished Baltic ply, and we're going to put a stain on this. And as time goes on, the stain will umber a little bit. It'll kind of yellow a little bit, and it'll bring the wood grain. The wood grain will pop right out, and it'll look really, really neat. And the goal is to have the finest flying piece of furniture in the world. That's kind of our
finest flying furniture. The FFF squadron.
Exactly. That's kind of the goal, because I mean, it's really going to be pretty.
What is that in German? He said that in German.
Oh gosh, no, I think those words up probably. It's a little beyond my.
It'd be the flying fliegen.
Yeah, exactly. But we want it to look really authentic and really German, and so it'll be this natural color, and then we'll probably pop it a little bit with some orange and black trim, just for visibility. And you know me, I like orange, black.
So you may confuse people when you get this to different shows or whatnot, thinking this is from way back when, and it's actually a 2019 or 2020, whenever this is completed. Yeah. So Holliday, tell me a little bit about this piece here. It looks very engineered, at the same time a lot of artistic value to it.
Sure. This is a bell crank, and it's made out of 3/16 inch 6061 T6 aluminum.
Okay.
And this controls the aileron cables out to the aileron on the wingtip.
And who made that for you? That's
well, it's interesting. We started off with a high school student here on our build team, Damon, and he went ahead and digitized off the plans all the shapes for all of our bell cranks.
Okay.
And then we had another member in the chapter who's retired now, but whose family business is still operating in metal fabrication. And they used a waterjet and actually cut out all of our bell cranks out of this piece of 6061 T6 aluminum.
Nice.
So that's how we got it. And Damon has gone on now to actually.
Where did you find this guy Damon at again?
He was a high school student that was interested and started helping us on the build, 3 or 4 years ago.
So he became part of your EAA chapter?
He was our part. Yeah, he's a chapter member, and he helped us out with the build here. And he needed a high school project to do, and he said, "Oh, I'll digitize those for you." And what is it? DXF file, I think, is what we needed for the waterjet.
Okay.
To cut these parts out.
And from here, he went on to where's he at today?
He's out with Boeing out in the Pacific Northwest, and he's in a program with them.
Wow! So you can start out working on kit planes and built planes and EAA chapters, and suddenly you're working for Boeing.
Yeah, it can happen. It can happen. And by the way, Dieter Reich, the designer of this airplane, was also the designer of the F-15 and the Eurofighter.
Really?
He said he did this as a hobby because he wanted something at the far other end of the
spectrum.
Speed continuum.
Sure,
yeah,
sure.
Exactly.
So this design does incorporate a spoiler as well?
Yes, one of the options on the ULF 1 was to incorporate spoilers, and so we decided we wanted to do that. I like spoilers personally. Although the airplane could be easily slipped to landing. It's got so much lateral air on the fuselage, you could get a nice rate of sink just by slipping it. But I think spoilers are a little nicer, and the nice thing about spoilers is when the airplane's on the ground, you can leave the spoilers up. So if a gust of wind comes along, it's less likely
not going to want to pick it up
to lift.
Yeah.
Yeah. So the spoilers will go up and down like this, and they'll be servo actuated with radio control airplane servos.
Is that what I see up there on that bay?
Yes, that's exactly it. Yep, we did that, and in order to develop that design, we had to make a mock-up section of the wing. I can show you that, which I took out in my wife's car, and we actually did road tests with this at 20% over VNE up to 70 miles an hour to make sure that all these servos would work.
Oh, really? So this was a mock-up to test the action of the spoilers?
To test spoiler actuation, because this hasn't been done before, with taking radio control model airplane spoilers and applying them to a full-scale aircraft.
Okay.
So what we had to do is make a test fixture or a mock-up fixture of a scale section of the wing. And what we did is we put this in my wife's Lexus, which is one of these hardtop convertibles, and we were able to mount it right behind the top of the windshield with the top down, and drive along with the spoiler mounted with the servo, and actually tested at various speeds on the highway. So we would actually test, and we would measure voltage and the temperature of the servo.
Okay.
Because what we found out is that a lot of the more modern digital servos would overheat and the motors would burn up.
Okay.
So what we ended up using was a digital servo, but with old-time motor, an old can brushed motor, and old-time
a stepper motor.
Brass gears.
A stepper motor type thing.
Yeah,
right?
and that worked the best.
I bet your neighbors were looking at you funny that day driving around with us.
People were looking at us like, what are you guys doing? We had 3 of us in the vehicle. One guy was taking measurements, another guy, me, was driving, and the other guy was holding the fixture in place.
Experimental aviation at its best.
That's
right?
it. That's how you do it.
So all these
those were all scrap, cut off pieces.
Yeah, little bits and pieces of wood eventually turns into something that is artistic, looking as this wing and an airplane.
But this is the finished plywood, and some of it's down as thin as 0.4 millimeters, 3-ply. Imagine the machine and the cutters and the
scrape
rollers
that
off.
And
the glue and like that puts this thin. And we would use a very thin plywood like this against a piece of foam here to keep the foam protected.
Right.
But with adding a minimum amount of weight. And then so it goes from 0.4 millimeters up to 1.5 millimeters was the thickest plywood that we used on the construction. So we've used 0.4, 0.6, 0.8, 1 millimeter, 1.2, and 1.5. So that's all, and very little 1.5 because that's really heavy for this aircraft.
Yeah?
Yeah, just a few.
That's funny to say, isn't it?
A few little reinforced sections with that.
So this is a mock-up?
This is a mock-up for the nose wheel, with a fairing and a steering section. So we make a lot of the mock-ups out of cardboard first to test out the design. This is CAD design at its best, but our CAD design is cardboard-aided design, not computer-aided.
Cardboard-aided design, all right.
And this is another example of cardboard-aided design. Ross Gressley is a mechanical engineer in our group.
Let me get that in focus there.
Sure.
Okay.
And we had to come up with the spoiler mechanism for the wing. This is a cross-sectional view. So this is the top of the spoiler. This is the hinge point on the spoiler. This is the linkage. This is the servo. The servo would actually be right here, and this is how we came up with the linkage actualization for the servos. Again, cardboard-aided design again.
And you didn't realize this, but when you're all said and done, you're going to create a pop-up book for children, and include stuff just like this, aren't you?
That's right, they can play with and dream about. But that's how we did it. That's actually how we came up with it. And what it is, it goes 2 degrees over center right here.
Okay.
So the nice thing about this is when the airplane's on the ground, I have a little grab thing on the top of the spoiler that I can pull the spoiler up and lock it into position, full spoiler, without using any electricity or without straining anything.
Sure.
And then when I want to put it down, all I have to do is push here, and I can put it right back down and have it locked down. Yeah, the original design for the spoilers on the ULF 1 are mechanical, like a conventional sailplane with levers,
okay,
and pulleys and bell cranks and levers and sticks and all those sorts of things. But we decided that just one servo here with the actuation which we just showed on the cardboard-aided design, and then one wire running down through the wing into the cockpit to a little controller box will be all we need for spoiler actuation.
Right.
So it cuts down a lot of complexity, a lot of weight, a lot of fabrication time to make all these little pieces. But I have a feeling the R&D time we made up for it in that, because it probably took as much time in R&D as it did to probably make it this way.
That's all fun and games, right? You're still building.
Well, yeah, but it was a project.
Sure.
And it was fun.
So what? Obviously, you're doing a lot of woodwork here. What are some of the power tools or hand tools that you've needed to basic?
My shop is very, very rudimentary. I don't really believe in having a lot of really fancy stuff that you only have to use once or twice a year. But the main tools are a 12-inch disc. This has been real important for getting pieces fine-tuned and getting angles
rounded
set
or
right.
whatnot, yeah.
And then a nice Craftsman saw here, bandsaw, 12-inch bandsaw. And then I've got another little tool over here, a little Rockwell tool here for cutting small metal pieces.
Okay.
And then a little small hobby jigsaw for making a lot of the other pieces, because this airplane is really a big radio control airplane. Really.
Sure.
In terms of, it's just scaled up.
Yeah.
So all the stuff I used to use in modeling, we can apply directly to this project.
So you can start out small and get to life size very easily.
Exactly. Hot glue guns are real important for putting assemblies in temporarily.
Okay.
While you're shaping and fitting.
Pro tip: use a hot glue gun to hold things in place.
Hot glue gun, and then you can easily pop it apart and scrape it off when you're done. And we've used special tools for getting wood shavings all off before we glue. We're doing a lot of that kind of stuff. Little small hand planes for shaping parts.
Okay. We
haven't used this big spoke shave very much, but on a few things we have. And compasses for making radiuses.
Sure.
And it's just a whole lot. Plumb bobs for truing things. And anyway, we have a special bow, and then we use spider wire a lot too for getting straight edges. So we stretch the spider wire out and use that as an alignment tool, because you get a nice straight edge over a long distance for like setting the trailing edges and that sort of thing. We use a lot of that.
So, and then again, kind of the basic tools that you use a lot of clamps.
A lot of clamps.
Wood and glue work. Yeah.
And this is the T88 epoxy. That is the main adhesive that we've used for most of the structure.
Okay.
And then we've used the West Systems epoxy resin for a lot of the fiberglassing work, like on the spoilers. And then we've also used this as the resin for the carbon. And we don't have the wingtips here either, but we made wingtip plugs, which are combinations of pieces of foam that are laminated together and carved. And here are all the shapes. Here's a stack of shapes for those. To get the contours right, you have to have stations. And these are all every 2 inch there's a station for a shape.
Those are your templates?
Our pilot man here is starting to fall down. We used him to figure out how we were going to position my body in the cockpit. But anyway, you had to make all those and then carve out the tips. And the tips are a combination of wingtip and winglet, all in one structure. And Ross Gressley has those right now. We're going to do the final fiberglassing and shaping of those. They're up in his shop.
All right, well, thank you very much for taking the time to give us a tour of your shop and what you've done in the past six years. And we look forward to the completion of this, and hopefully we can stay in contact. And when you do complete it, come back up and take some video of it flying. I'd love to see this fly. I'm sure a lot of people out there would love to see this fly.
Yeah, me too. Well, Brian, it's been a pleasure. I'm really glad you came by. Thanks a million.
Thank you.
All right, take care.
Okay, guys, time to close up the shop. Remember to hit that like button, subscribe for more videos like this, and remember, just build it. I'll see you on the next one.